Module 3, Section 3, we will look at more examples of solving linear equations and talk about the general process involved in solving any linear equation you may come across. So to solve linear equations in one variable, you see that there are 6 steps. Let me mention that step 1 is optional. I know many of you will choose to do this, will choose to eliminate fractions or decimals, but just know that if you would rather grind it out with the decimals or with the fractions, that is perfectly fine. As you go through the steps, you can see basically steps 2 and 3 say we want to simplify each side of the equation. Step 4, we move all the variable terms to one side, all the numbers to the other side. In step 5, we divide by the coefficient of x. In step 6, we haven't done much of this, but you can always check the solution by substituting whatever value you get at the end back into the original equation. And if it satisfies the equation, gives you the same number on each side, it's a correct solution. If it doesn't, then you know before you enter the answer that you need to try again. That some mistake was made as you're working the problem. So for the remainder of this section, let's work on solving equations. We start with 13 minus 2 times a minus 1 equals 6 plus a. So we go through the process. We don't have any fractions. We do need to simplify the left-hand side of the equation. The right-hand side is okay. There aren't any like terms. But on the left-hand side, we have this minus 2 that needs to be distributed to both pieces in parentheses. So we bring down the 13. Negative 2 times a is minus 2a. Negative 2 times, we can consider this negative 1. Negative 2 times negative 1 is a positive 2. That equals 6 plus a. Staying on the left-hand side, we combine like terms. 2 and 13 will add to make 15. So we have 15 minus 2a equals 6 plus a. Now that we've simplified both sides of the equation, I draw my vertical line through the equal sign to separate both sides, just to give us a clearer perspective when we start adding, subtracting, multiplying, and dividing. So I want to move all of my variables to the left. That's sort of standard procedure. If you would rather move your variables to the right, that's fine. But every example, I will move my variables to the left. So we subtract a from the right side so that the opposite a's will cancel. On the right side, we're left with 6. On the left side, we have 15. Negative 2a minus a is negative 3a. So we have 15 minus 3a equals 6. I continue to draw this vertical line through the equal sign. So all of my a's are on the left side. Let's move all of the constants to the right side. So we subtract 15. And we do this so the opposite 15s will cancel. The left side becomes negative 3a. And that equals 6 minus 15, which is negative 9. Now that we have all of our variables on the left side, all of our numbers on the right side, we can divide by the coefficient of a. Remember, we do not change this sign. We keep it exactly the same. Negative 3 divided by negative 3, those cancel. On the left side, we have a equals negative 9 divided by negative 3 is a positive 3. And you could take that positive 3, plug it back into the original everywhere you see an a, and you should get the same number on both sides of the equation if that is a good solution. The next example, we have decimals. And we worked one example in the previous section where we had decimals, and we eliminated those decimals before we started. We'll do the same thing here. Remember, we have to determine where the decimal ends. The first decimal ends in the hundredths place, second decimal ends in the hundredths place, third decimal ends in the hundredths place. And so we can multiply each term by 100. I'm going to show you a shortcut. We could also move each decimal the same number of times to the left or to the right. So since everything's in the hundredths place, we're going to move all the decimals twice to the right. Let's see what that looks like. 1, 2. So that 0.60 will become 60x. There's the next decimal, 1, 2 times. That becomes plus 45 times 160. Now this will only affect the decimals. It will not affect the whole numbers. The last decimal, 1, 2. So we bring down our equal sign. This equals 30 times 146. Okay, so that is another method other than multiplying by 100, which would have been perfectly fine. That's another method to remove the decimals from the problem. Once we've done that, we need to simplify by multiplying first 45 and 160, which is 7,200. Bring down the 60x. So we have 60x plus 7,200 equals, we multiply 30 times 146, and we get 4,380. Okay, we have simplified the left-hand side, we simplified the right-hand side. I draw my vertical line through the equal sign just to separate left side and right side. All of the x's are already together on the left side, so let's move the constants to the right. We're going to subtract 7,200. And the reason we do that is so that the opposite 7,200s will cancel. We're left with 60x equals. On the right side, we take 4,380 minus 7,200. That will give us a negative 2,820. Now that we have all variables on one side, all numbers on the other, we divide by the coefficient of x. Remember, we're not dividing by x. Don't put 60x in the denominator. We don't change the sign either. On the left side, 60 divided by 60, those cancel. So we're left with x equals, on the right side, we divide by 60, and that gives us negative 47. That works out smoothly. Now, I will say, if you had a choice between putting in a fraction or a decimal in this problem, you would want to use the decimal because we started with decimals. Just make sure you follow the instructions and look at all of the instructions for every problem in your homework. In this example, we have a fraction on the left-hand side. We have parentheses in the numerator of that fraction. And on the right-hand side, we do not have like terms. So let's start by distributing the 4 on the left-hand side in the numerator. So 4 times x will be 4x. 4 times 4 is 16. So 4x plus 16 all over 3 equals 3x minus 4. Now remember, we don't like the fractions in our equations, so we can get rid of those. Typically, we would have more than one fraction, and in that case, we would multiply both sides by the least common denominator. Because we only have one fraction, we only have one denominator, so we will multiply every term by that denominator. So multiply the left side by that denominator and the right side by that denominator. Now remember, whenever we are multiplying, or whenever we have a factor in the numerator and the denominator that are the same, we can cancel those factors. So the 3's on the left side cancel. That leaves us with 4x plus 16 equals. You may notice I drew parentheses around the 3x minus 4 on the right side. That's because we must distribute this 3 to both pieces inside of those parentheses, both pieces that were originally on the right-hand side of the equation. So we have 3x times 3 is 9x. 3 times 4 is 12, so we have minus 12. And now we've taken care of the fraction and worked the problem just as we have on previous examples. I'm going to draw the vertical line through my equal sign just to separate left and right side. Let's move all the variables to the left. So we subtract 9x from both sides. We do that so that 9x and negative 9x, which are opposites, will cancel. On the right-hand side, we're left with negative 12. On the left-hand side, 4x minus 9x is negative 5x. Everything else stays the same. We have plus 16. So negative 5x plus 16 equals negative 12. Still have our vertical line through our equal sign. All of our variables are combined on the left. We need to move the 16 to the right side. So we subtract 16 from both sides of the equation. The 16 and negative 16 are opposite, so they cancel. Let's go up to the top. On the left-hand side, we have negative 5x. So negative 5x equals, on the right-hand side, negative 12 minus 16 is negative 28. Because we are multiplying x and negative 5, we cancel that negative 5 by dividing on both sides by the same exact number. So on the left side, the negative 5s cancel. We're left with x equals negative 28 over negative 5. Now, 28 and 5 don't have any common factors, but you may notice that the numerator and denominator are both negative. Anytime we have two negatives or two of the same sign in division, that should be a positive answer. So you may think of it as these negatives canceling one another out and creating a positive fraction. And the answer will be x equals 28 over 5. Here we have another example with fractions. X over 8 plus 4 equals x over 8. We don't need a least common denominator. We already have it. We only have one denominator, and that is 8. So in order to eliminate the fraction, let's multiply all three pieces, all three terms, by 8. So we have 8 times x over 8 plus 8 times 4 equals 8 times x over 8. And we can rewrite this 8 each time as 8 over 1. When we do so, we multiply across the bottom and across the top. So that gives 8x over 8 plus, let's rewrite this 4 as 4 over 1, 32 over 1 equals 8x over 8. When we reduce each fraction, this gives us x plus 32 equals x. Okay, we draw the vertical line through the equal sign. Let's move all of our variables to one side, all of our numbers to the other, and see what happens. So on the right side, we will subtract x. When we subtract the x's on the right side, they are opposites, so they cancel. When we subtract x's on the left side, they're also opposites, so those cancel. So on the left side, we're left with just 32 equals. Now when we say opposites cancel, really opposites add together to form 0. So on the right side, x minus x is 0. Now this is something new. We have a statement where all of our variables have canceled and we're left with just numbers. When this happens, we'll see one of two things. We will either see a true statement or a false statement. So let's look at the statement we have left. We have 32 equals 0. We ask ourselves, is this true or is this false? And clearly 32 does not equal 0. So this is false. This is what a false statement means. A false statement means it doesn't matter what value you plug in for x, it will never, ever satisfy the equation. And so in that situation, we say that there is no solution. There is no possible way we could solve this equation. Let's try another example. When we look at the left side and the right side, we see the right side does not have any like terms, nor can it be simplified. On the left-hand side, we have parentheses and possibly like terms afterward. So we need to simplify the left-hand side. We'll start by distributing 3x to both pieces in parentheses. 3 times 7x is 21x, plus 3 times 9 is 27. Bring down the minus 3. The right-hand side will stay the same. Now we combine like terms on the left-hand side. 27 minus 3 is 24. Everything else stays the same. So 21x plus 24 equals 21x plus 24. Now at this point, you may notice something peculiar has happened. If you don't recognize it, I will go one more step before we actually stop and talk about what's going on here. So draw a vertical line through the equal sign. We want to move all of our variables to the left side, all of our numbers to the right side. So we subtract 21 from each side, 21x from each side of the equation. On the right side, 21x and minus 21x are opposites, so those cancel. On the left side, 21x and minus 21x are opposites, so those cancel. So on the left side, we're left with 24. On the right side, we're left with 24. And we're left in a somewhat similar situation to what we saw in the last example. The variables canceled, and we were left with just numbers. And so we have to ask ourselves again, is this a true statement or is this a false statement? 24 equals 24. And this will always be true. Now, when a statement is true, when an equation is always true, that means it doesn't matter what value we plug in for x. It could be 1, it could be 100, it could be negative 1,000, and so on. The equation will always work. And in a situation where the equation always works, we say that the equation has all real number solutions. Sometimes we may say it has infinitely many solutions. Either way, we could use any real number in place of x, and it would still be true every single time. Let's try an example where we have a fraction on each side. We have parentheses that need to be distributed through in the numerator of each of those fractions. So let's start by distributing the 6 on the left-hand side and the 5 on the right-hand side. So multiplying through the 6, 6 times x is 6x, 6 times negative 11 is minus 66, all over 5. And that equals 5x plus 55 all over 6. Now, one thing we've done in the past when we have fractions is multiply both sides by the least common denominator. That would be perfectly fine to do that in this case. I'm going to show you one variation of that process where we eliminate one fraction at a time. Let's create a little bit of room on this last step, and let's eliminate the fraction on the left-hand side first. So because we have a 5 in the denominator, let's multiply both sides by 5. The reason we would do that to begin with, when we multiply and divide by the same number on the left-hand side, that cancels. So we're left with 6x minus 66 equals. Now when we multiply a fraction by a whole number, we can rewrite that fraction, or that whole number, as a fraction. So we write 5 as 5 over 1. And since we have multiple terms in the numerator, we would actually need to distribute that 5. So we multiply both pieces in the numerator by 5. We have 5x times 5 plus 55 times 5. And when we work that out, we get 25x plus 275. But we still have the fraction. It's still all over 6. So now we're going to do the same thing, except with the 6 instead of the 5. So now we multiply both sides by 6. And we do that because when we multiply and divide by the same number on the right-hand side, those numbers cancel. So on the right-hand side, we're left with 25x plus 275. On the left-hand side, we must distribute the 6 to both terms inside parentheses. So we multiply 6 times 6x, and that gives us 36x, minus 6 times 66 will be 396. We've simplified each side of the equation, We've eliminated the fractions. Let's draw a vertical line through our equal sign and start moving terms. So we move the x's to the left side by changing 25x to minus 25x on both sides of the equation. 36x minus 25x is 11x. Everything else stays the same. Minus 396 equals positive 25x, negative 25x cancel. So we're left with 275 on the right-hand side. Let's rewrite this near the top so we have a little bit more room. So we have 11x minus 396 equals 275. Draw the vertical line through the equal sign again. Let's move the numbers to the right. So we add 396 to both sides of the equation. When we do that, the opposite 396's cancel. We're left with 11x equals 671. We divide both sides by 11. Remember, just 11, not 11x, not negative 11. On the left-hand side, 11 divided by 11, that cancels. We're left with just x. On the right-hand side, 671 divided by 11 actually works out to be a whole number, 61. If that did not work out to be a whole number, we would leave it as a fraction in reduced terms. Let's try one more example. Throw in lots of fractions just so we can get good practice. Now in this problem, we look at the left-hand side, and we see that we have a few like terms, but they're fractions with different denominators. On the right-hand side, we don't have any like terms. Let's start this problem off using the step one that was shown in the very beginning of this video, where we eliminate all of the fractions. To do that, remember, we need a least common denominator. We look at our denominators. We have a 4, we have a 6, we have an 8, we have a 24. So we would have to find the least common denominator of 1, 2, 3, 4 numbers. You would go through that process and make your prime factorizations, multiply your prime factors, just like was shown in Module 1 when the least common multiple was introduced. Or you could simply verify by looking at the multiples of 4 and 6 and 8 and 24. But as you go through this, the least common denominator will be 24. Once we find that LCD, we multiply each term by 24. So let's write that down. 24, and anytime I have a fraction, I will rewrite 24 as 24 over 1. So 24 over 1 times 7/8 x minus 24 times 3 plus 24 over 1 times 1/4 x equals 24 over 1 times 5 over 24 x plus 24 over 1 times 1 over 6. Now, in order to save space, I'm not going to show every step in this process, but remember, you multiply your numerators, multiply your denominators, and because we multiply by the least common denominator, they should divide evenly, and you have nothing but whole numbers or integers as coefficients. So once you go through that process, you would have 21x minus 72 plus 6x equals 5x plus 4. You may want to pause the video, go through that process on your paper, and then once you get all of your fractions simplified, your next line should look like what I just wrote on the board. On the left-hand side, we can combine like terms. We have 6x, 21x, and those will combine to make 27x. So we have 27x minus 72 equals 5x plus 4. We've done all the simplifying we need to do on each side. Let's draw a vertical line, separate sides, and start moving terms. So we subtract 5x from each side. And when we do that, the opposite 5x's on the right-hand side cancel. So the right-hand side is left with just 4. On the left-hand side, 27 minus 5 is 22. So we have 22x minus 72 equals 4. Draw my vertical line again. Let's move the numbers to the right side. So we add 72. When we add 72, the opposite 72's cancel. And we're left with 22x equals 76. Let's take this and write it closer to the top so we have more room to work. So 22x equals 76. We divide both sides by 22. 22 divided by 22, those 22's cancel. We're left with x equals 76 over 22. Now, anytime we have fractions in the answer, we want to make sure that those fractions are reduced to lowest terms, that they're simplified. So we can rewrite 76 as 2 times 2 times 19. 22 is 2 times 11. There's a common factor of 2 that cancels. When we multiply what's left, 2 times 19 gives us 38. So x equals 38 over 11. And that would be the simplified answer. Some of these questions will take quite a while as you go through the steps. Make sure you're patient. Make sure you double check so that you've written down all of the negative signs correctly, because one negative sign in the wrong place or a lack of a negative sign could throw off your entire solution. And you don't want to work these problems any more times than you have to, especially because of a simple mistake like that. Work hard, ask questions, and do the best you can.